So you find control nodes really confusing to get into, and no matter what you do, it feels like you just can't get them? Well, I'm here to change that. Before we start, this video is not a full list of all the control nodes available or about all their properties. That's not practical. This video will go into explaining all the tools and concepts involved in making user interfaces in Godot. We'll start by looking at the concepts, while also discussing common pitfalls and the thought process behind breaking down seemingly complex layouts and actually contextualizing them into those basic concepts. At the end, we'll be looking at a live example where I walk you through the process of designing a simple but elegant layout, while sprinkling in some super spicy tips that'll make your life a lot easier. Stick around for that. Let's get started. Every control node has some basic transform properties such as position, rotation, size, and scale. The position is always visually the top left corner of the node. This blue box here is the game window's resolution. This can be changed in the project settings. So if I were to set the position of my panel to half my project's resolution, the top left corner of the square would be exactly at the center of the game screen. The size property, not to be confused with scale, defines how far the bottom right corner is in pixels, relative to the top left corner. This means that increasing the size of the node will only ever make a control grow towards the right or down. The scale can be thought of as a multiplier for the size property. The final size of the node will be the size multiplied with the scale of the node. For example, if the size of the node was 100 pixels on the X and the scale was 2 on the X, the resultant size would be 200 pixels. One important thing to note here is that the scale is dependent on the pivot offset property, which is the offset of the pivot point from the top left corner. This little plus icon shows where the pivot point of the selected node is. By default, since the pivot point is at the position of the node, increasing the scale will make the node grow similar to how increasing the size would. However, if I was to set the pivot offsets X to half the size as X, you'll see that increasing the X scale makes the panel grow in both directions. If I set it to half the size on both axes, it grows outwards from the center. Do note that the pivot offset does not affect the size property in any way. The rotation property is fairly straightforward. Only thing to pay attention to is the fact that it also respects the pivot offset just like scale. The order of nodes in the tree is important. Nodes that are lower in the tree are stacked on top visually. So when I move this panel below the label, the panel renders on top of the label. Anchors are used to design layouts that work properly with any aspect ratio. These green pegs here are the anchors of a control. The anchors are the sides of the rectangle that these pegs would make. Left, right, top, and bottom. You can see these in the inspector if you set the layout mode to anchors and the anchor preset to custom. Each anchor is a float within the range of 0 to 1. You can think of it as a percentage. A value of 0 would be 0%, 0.5 would be 50%, and 1 would be 100%. If you also think of your window's resolution in the scale of 0 to 1, starting from the top left corner, understanding anchors is fairly simple. Let's draw a line right at the center of the window on the x-axis. This would be at 50% of the whole range, or 0.5. Now if I set my right anchor to a value of 0.5, you'll notice that the green pegs on the right show up at the center right where I drew that line. Now if I change the target resolution in the project settings and reload my project, you'll see that the same value of 0.5 for the right anchor has shifted to the halfway point of the new resolution. So essentially, the number of pixels in our window resolution no longer matters. We simply start to think in terms of the percentage of screen space away from the edge of the window. All this theory is cool and all, but who asked? You did. Imagine a situation where you wanted to place this health bar right at the middle of the screen. You send the game off to a friend and it looks fine on their end. Nice. But then you send it to another friend that plays at a slightly longer resolution and yeah, that's no longer centered. Another example, you have some neat UI showing the player some really important information about your game. The solution to both of these situations? Anchors. Here, if we set our anchor to be at the horizontal center, our health bar is positioned at the center of the screen no matter how wide the resolution is. However, this still breaks if the vertical resolution of our game is changed. To fix this, we'd have to set the anchor to be at the bottom middle of our screen. This will make sure that the element is anchored to the bottom vertically and the center horizontally. And here, we can anchor it to the right center of our screen. When you're using anchors, if you have the preset set to custom, you'll see a section called Anchor Offsets. These are pixel offsets relative to the respective anchor. I have a panel here. Let me reset its size and position and set its anchors to something like this. Now you'll notice that the anchor offsets already have some values. If I reset each of them, you'll see that the panel takes up the entire space within the anchors. To demonstrate this further, I'm going to set the anchors to take up the entire screen and also reset the offsets. Alternatively, I could also use the full rect anchor preset, which would be the same as doing both those actions. So now, if I were to switch the preset back to custom and set the left offset to 100 pixels, the panel shrinks and is now at a distance of 100 pixels away from the left anchor. In this case, since the anchors are set to the whole window resolution, the panel appropriately responds to the fixed offset of 100 pixels from the left edge of the window, no matter the size of the window. To see this on all sides, I'll set the right offset to -100. This value has to be negative because we want the offset towards the left of the right anchor. If I were to set it to +100, it would be 100 pixels to the right of the anchor. Same goes with the top and bottom offsets. Now, no matter how the window is resized, the panel's size property is automatically adjusted to work with the offsets that we set. Why is this relevant? Let's go back to that health bar example. We saw earlier that the size of the health bar is unchanged when the window size changes. But let's say you wanted it to stretch based on the window's resolution. For that, we would need to set the anchors to span the entire length of the window horizontally, and then set our offsets appropriately. And there we go. The bar stretches when the window gets wider. One thing to pay attention to is the fact that resizing a control node automatically sets the offsets appropriately. If you're using the custom preset, that is. Toggling this white anchor button makes the resize action also move the anchors proportionally, which means that the anchor offsets remain constant. And finally, to wrap up anchors, we can now talk about anchor presets. You'll find a few really useful presets under this Super Smash Bros. Looking button. Each of these buttons does two things when clicked. First, the anchors are set based on what preset you select, and the second, all the offsets are set to 0. There's a little asterisk on that point, I'll get to that in a second. To see this in action, if I set my panel's anchor preset to top left, you'll see that it gets anchored to the top left corner. You can no longer see the panel anymore, and that's because of the fact that the anchor offsets are set to 0, which in turn affects the size. Since our anchors are just focused at that single point, and we have 0 offset from that point, we end up with a panel with a size of 0. When I change the panel's size, you'll see that the offsets react, and when I change the offsets, you'll see that the size reacts. Though sometimes it seems that the offsets are not set to 0, and I couldn't figure out what causes this inconsistency. If someone knows, please let me know. But anyways, if you fundamentally understand how the anchors and offsets work, this is merely a slight inconvenience. You'll immediately know what to do to get the result you want. One really important thing to know is that the presets are not relative to the window resolution, they're relative to the parent node's rect. If I create a control node as a child of this panel and play around with the presets, you'll clearly see that behavior. The anchors are placed relative to the panel. Only exception to this is the root node, which is relative to the window resolution because it doesn't have a parent. If you're still confused about anchors even after watching me ramble on about them for this whole time, don't worry, that's expected. You would have noticed already that this is not a step-by-step tutorial. My aim is to introduce the relevant concepts and provide you with practical examples on why they're relevant. And hopefully I've done at least a semi-decent job at that so far. Play around with them yourself once you finish watching this video. When you do enough of that, it should all start to make intuitive sense. Custom minimum size. This property, in my opinion, is the most important property to get a good grip of when understanding how to make UI in Godot. It's actually extremely straightforward to understand. All it does is restrict the control size property from going lower than itself. That's it. Returning to that same example again, if we made our window too narrow, the health bar just shrinks into itself. We can limit this by giving it a custom minimum size, so that its size cannot go any lower than this. This property has some unconventional use cases, but it's difficult to talk about those in isolation, so I'll try my best to bring them up if they come up. Oh, and this property becomes really important when using containers, so let's discuss those now. A container is a node that arranges its children automatically, as well as set its own size based on the number and size of the child nodes. What this means is that a direct child of a container cannot be transformed freely. These properties are managed by the parent container, based on what type of container it is. This might sound really restricting, which it kind of is, honestly. But learning how to navigate around this restriction will help you see the real power of containers. But before we learn how to do that, let's quickly take a look at a couple of important containers. The Hbox container stacks all its children horizontally. The order of its children in the tree is the same order that the elements are stacked in. The Vbox container is exactly the same, but vertically. The margin container lets you provide some space between the edges of its own bounding box and its content. And finally, the panel container encapsulates its children and draws a panel within its bounding box. 90% of your UI is just going to involve using these 4 containers. Building UI just involves nesting these containers in a logical manner. It's important that you understand what each container does and how they interact with each other. A common pitfall is to use something like the panel container and wonder why you can't arrange its children easily. That's because container children cannot be transformed, and all the panel container does is effectively restrict its children within its bounds. If you want to arrange the children vertically, you'd need to use a Vbox container as a child of the panel container, and child those nodes to the Vbox container. If you want to add some space around the content, that's the job of the margin container. You'd have to add it between the panel and the Vbox containers. Why does it have to go exactly over there? That's because the Vbox adjusts its own size based on its children, and we want the margin container to add margins around that resultant space. And the panel container adjusts itself to the resultant size of the margin container. It's all about nesting these containers in a logical manner, most commonly Vbox and Hbox containers. You can break down almost any layout by thinking of all the horizontal and vertical sections in terms of these containers. This layout just uses a Hbox container to split it into 2 main sections. The left section is simply a Vbox container for each item, and the content of each item in the list is just another Hbox. The right section is again a Vbox, and these sections are Hboxes. Throw some margins and panels in there, and there you go. It's really that simple. Moving on. Container children cannot have anchors, so you won't be able to set them manually or use the presets we used before. However, when you select a child of a container, you should see this new button show up on top. This button contains container sizing options that dictate how the child should be laid out within the parent container. Using these buttons would be the same as setting the container sizing options in the inspector. Let's say I had a panel container with a child panel. When I play around with the horizontal alignment of the child panel, you'll see that it reacts accordingly. The same happens with the vertical alignment. The options on the left side are all shrink options. They shrink the child to its minimum size and align it to the respective side, and since the container children cannot have their size property manually set, they just shrink to 0 by default. The options on the right are fill options. They make the child take up the entire available space in the respective axis. But what if I wanted my panel to be a section on the left side and have it actually be visible? We use the custom minimum size property. I can set the custom minimum of my panel to say something like 100 pixels on both axes, and set the horizontal alignment to shrink begin, and then I can set its vertical alignment to be on top, middle, or center, or just have it fill vertically, so that it always stretches to cover the entire vertical size of the parent. Note that these alignment options are only relevant when the node is a child of a container. For example, if I look at the root node here, it seems to have the alignment options available, but when I set them, it doesn't change anything. This only takes effect if the scene is instantiated into another as a child of a container node. Something a lot of people have trouble with is positioning and sizing texture rects inside of containers. If you've had trouble with this before, this will hopefully start to make more sense now. I have a panel container here. I'll child a texture rect to it. We see that the alignment options work as expected, but there doesn't seem to be an obvious way to resize it. The trick here is to set the expand mode to ignore size, which will make our image shrink into itself if we were using any of the shrink options. And then what do? You guessed it, we give it a custom minimum. And now we can align it the way we want. You can also mess with the stretch mode property to dictate how the texture behaves within the bounds of the texture rect. Moving on, a common mistake is to try to set the vertical alignment of a Vbox child or the horizontal alignment of a Hbox child. This doesn't seem to work as how you might expect. If we take the example of the Hbox container, you cannot set its child's horizontal alignment because that's already controlled by the Hbox container, but you can set its vertical alignment. This confusion happens a lot, especially when someone wants to use the fill setting. Why aren't you filling to the full size of the container? Because for that, there's another option called expand. Only specific containers allow their children to have specific axes to set the expand flag on. Setting the expand flag on the container child makes the child take up the rest of the container's available space. I'll demonstrate this with using 2 panels within a Vbox container. Note that these panels have a custom minimum size set on their y-axis. Without it, they'd just shrink into themselves completely. So we have these two container children taking up a certain amount of space due to their minimum size. But the remaining space in the container isn't being occupied by any node. If I want the white panel to take up that remaining space, I'd have to set it to expand. If I wanted the orange panel to take up that space, I'd have to set it to expand instead. This will push away the white panel until all the empty space in the container is fully occupied. Here I can adjust the size of the white panel using its custom minimum size, and the rest of the space is automatically occupied by the orange panel. If I set both of the panels to expand, you'll see that they fight for an equal amount of the remaining space. I can use the stretch ratio property here to dictate which panel takes up more space. At the moment, it's set to 1 on both panels, but if I set the ratio to 2 on the white panel, it takes up twice the amount of space than the orange panel. You can add more nodes to this container and all of what I just described still works the same. Note that the stretch ratio does absolutely nothing if the expand flag is checked. A really common confusion, toggling this option here is not the same as toggling expand. Just pressing this toggle does nothing. Toggling it on and then selecting one of the alignments sets that alignment along with its expand flag. You can just use custom minimum or combo it with expand to have elements of different sizes inside of a VBox or Hedgebox container. A theme in Godot is a resource that contains information about how each control node type should look. Each customizable node type contains its own set of theme properties. You can set values for these properties for specific node types in a theme and apply that theme to your entire project. Now, whenever you create a node of that type, the values we set in the theme are used by default. I won't be going into more detail about themes here, but let me know if you'd like to see a dedicated video on themes and how to set them up. Though what I've just described here should be enough context to get us into our next topic: theme overrides. On control nodes that have theme properties available, which is most control nodes, you'll see a section in the inspector called theme overrides. Here you can enable an override and set a new value. Note that unlike themes, which affect entire node types, overrides are only applied to individual nodes and not node types. So if I had two labels where I override a theme property of the first one, the second one will still use the default value defined in the theme for the label node type. Another thing to note here is the fact that the value you see here is not the value that's currently being used if the property is not checked on. The override only takes effect if it's turned on. For example, a VBox container has a separation theme property that you can use to add some space between each child, and by default, even though we see a 0 here, it looks like there's some space between the panels. That's because this override isn't being applied, and it's just using the value defined in the theme for the VBox container. When we do turn it on, we see that there's no separation between the children now. These theme properties are really useful to customize the appearance of our UI elements. I didn't mention it earlier, but the way you set the margins of a margin container is by using its theme properties. The margin container has properties to set the margin on each side, and it's not just containers. Almost all control nodes, even something like a label, have a lot of really neat theme properties that you can override and customize to your liking. Anytime you want to customize the appearance of any control node, the first place you should look at is that class's properties, of course, but the next place to look at is its theme override section. Some control nodes have theme properties that take a style box. Style boxes are resources that define the style of a control node's region. You can find out if a node can take style boxes by checking if it has the styles section under its theme overrides section. The simplest node that can take a style box is a panel. You can create a style box by right-clicking on the slot and selecting the type of style box you want to create. The most common type that you'd be using is a style box flat. Click on the resource to expand it. You can give it a color, border, rounded edges, and there's a few other properties in there. You can hover over them to see their documentation, and they're fairly straightforward. I'd recommend creating a simple panel node and just messing around with the stylebox properties if you've never used the stylebox before. They're really simple to use, and you can make some neat looking layouts with them with minimal effort. A really common pitfall happens when duplicating nodes that have styleboxes. When I duplicate this panel and change the color in its stylebox, you'll see that this changes the color of both styleboxes. That's because styleboxes are resources, and duplicating nodes just copies references to the same resource. It doesn't duplicate the resource object. To make these two styleboxes independent, I'd have to right-click on one of them and press Make Unique, which makes it a completely separate object, and now I can change their properties independently. And finally, I'll walk you through the process of making this simple layout. I'll start with creating a panel container and anchor it to the center of the window. I'll give it a style box flat with a nice grey color. And while we're here, I'll give the style box a 1 pixel border. I'll also give it nice round edges by setting the corner radius properties here. Really useful tip. You can press tab to focus on the next property input to be able to easily fill in a series of values like you saw me do just there. Let's add a background to our scene so we don't see this ugly editor grey. I'll add a color rect node as a sibling and set its anchor preset to full rect. I'll need to move it above the panel container in the tree so it renders behind it. I want to set its color to the same color as the panel so I can look under the recent colors section to pick that color easily. Note that you can save colors that you use often in the swatches section here. Now, I'll create a label inside the panel container and give it some sample text. Looks like we need to stack elements vertically, so I'll create a VBox container here and move the label into it. I'll set the label to align to the left, so that when we eventually make our panel container bigger, the label node aligns to the left. I'll duplicate the label with Ctrl D and use that as the subtitle. Under theme overrides, I'll override its font size as well as its color. The font looks really blurred by default. To fix this, I'll go into the project settings and search for MSTF, and in the theme tab, I'll toggle this option on. I'll make sure to save my scenes, and once I reload my project, boom, super crispy text. It's a night and day difference. I cannot believe this option isn't on by default. All our elements getting stuck to the walls is starting to annoy me. So I'll create a margin container inside the panel container and bring all the content inside it. Under theme overrides, I can give it some margin values on all sides. Looks like the metrics are laid out horizontally, so I'll create a hbox container inside the VBox and create a label and a progress bar node and set it to expand so it takes up the remaining space. I need to reduce the font size of the metric label again, so I'll use this opportunity to show you another way to do it. I'll create a new label settings resource on the label and set the font size there. I can duplicate this node using Ctrl D and move it lower in the tree to put the label at the end of the hbox. This method of using the label settings resource is useful here because now if I decide that I want to change the font size, changing it on any one of these labels will change it on both. That's because they're sharing the same label settings resource. By the way, with the scene tree focus, you can hold Ctrl and use the arrow keys to move the selected node up and down the sibling hierarchy. Let's name some of these nodes properly because UI trees tend to get out of hand really easily if everything just has placeholder names. On the progress bar, I'll uncheck show percentage, which will make the bar shrink. I'll set the vertical alignment to center and give it a custom minimum to define how tall I want it to be. You can use the up and down arrow keys with a numeric field selected to increment or decrement it. Hold shift for 10 unit increments, control for 100, and alt for 0.1. It's a bit hard to see here with my default theme, but when I zoom in closer, you'll see that the progress bar has a dark gray region. This is the background of the progress bar. When I increase the value property, there's another bar that overlays on top showing the progress. I can control the appearance of each of these by creating stylebox overrides for them. I'll give the background a stylebox empty, so I just have the fill bar visible, and I'll give the fill a stylebox flat. I'll set its color to a nice blue and give it some rounded corners. Turning off anti-aliasing makes the bar less pixelated. I can use a V separated node, move it below the first label and set it to expand to add some space between the first label and the progress bar. Remember I set the progress bar to expand earlier? So now the separator and the progress bar are fighting over the remaining space in the hbox. I can set the stretch ratio on either one to define who takes up more space. I'll set the progress bar's fill mode to end to begin to match the reference. I'll duplicate the metric hbox to create the second one and set the relevant properties. These progress bars don't line up properly due to the text being different in length. So I'll give both the percentage labels on the right a custom minimum on the x-axis and set their horizontal alignment to right. Note that I'm setting the label property here, not the container alignment. At the end of the VBox, I'll create a button, set its text, set its font size override, left align it, set its custom minimum, give it a stylebox flat, color, corner radius, and turn off anti-aliasing. I'll also add some content margins in the stylebox properties to give it some padding. I'm noticing that the title elements, the metrics, and each of those sections as a whole have different amounts of space between them. So just setting our VBox separation wouldn't really cut it, because they'll all have the same space. What we can do is create separate VBoxes for each of these sections and place those in the main VBox, so that we can give each of them their own separation values. So I'll create another VBox for the titles and place them inside. I'll do the same with the metrics as well. Now I can give each of them their own separation overrides. For the spacings here, I'll create a head separator node and place it between the two new VBoxes. I'll then give it a stylebox empty, set its separation, and then duplicate it to adjust it for the bottom spacing. Now I'd like to go back and adjust the size of my panel container, but when I click here, it keeps selecting the margin container on top of it, which gets really annoying. Holding Alt and right clicking brings up a list of all the nodes under the mouse, and you can select the one you want here. Alternatively, you can press the lock icon up here to lock the selected nodes. Note that you'll still be able to select the children. If you don't want to select any of the children at all, also toggle the button next to the lock. I'll lock the margin container and now I can select my panel in piece. I'll adjust its bounds while holding Alt so it scales from the center. If I try to move the panel by dragging it from anywhere in the middle, it's going to select one of those elements. What I can do is hold Alt and drag from anywhere to move the selected node and position it the way I want. Finally, I can now top it all off by setting the panel container's border color to a lighter gray. And there you have it. Wait a second. This looks familiar. Oh, yeah. If you found this video helpful, I'd really appreciate it if you could subscribe. This was a lot of work. I have some ideas for a sequel discussing control nodes in greater detail. Let me know if that's something you'd be interested in, or if you have any other ideas. Oh, and I recently started doing beginner Godot mentorship on Fiverr. Full disclaimer, I am no expert. But if you're a beginner to programming C# or Godot, and you're struggling with learning, I can give you a head start. Link in the description. For 100 tips on Godot, check out these 2 videos. Oh, and I promise you they aren't full of filler tips that everyone knows already. I'm fairly certain you'll learn something new. Anyways, thanks for watching, see ya.